Alright, we're taking a look at 1.2 growing dots, what we did in class. So let's just jump right into it. So we can see we've got this graphic here. It says describe the pattern that you see in the sequence of figures above. So what you really should be doing on this is trying to answer this on your own and then watching the video to kind of see where you're at. So you should probably pause it right now. Okay, and try to answer all these questions. So describe the pattern first, how you see, what's going to happen. Okay, number 2, assuming that it continues in the same way, how many dots are there at 3 minutes? So what would be the next one to look like? Okay, then can you figure out how many dots there are at 100 minutes? Okay, so that's where we want you to go first. So pause it, take a look at those, and then come back to the video, and let's see what we got. Because the power in this is you doing it on your own, not just watching me do it. And you can even take a look at question 4, right? How many dots are there at t minutes? Okay, and go from there. Alright. Alright, so taking a look of how you describe the pattern. So there are a few different ways that you can kind of just see the pattern, and I've got them right here. So you may have seen it starts with one dot, and then we add a dot to each arm as we keep going. Okay, you may have also said there's 4 different arms, and each arm is growing by 1. Okay, or kind of like this one up here, where each dot, each time we go around, we're adding another dot. Okay. So they're all kind of the same, but describing, the pattern that you see. Somehow we're adding 4 dots each time, right? So it says, assuming the pattern continues in the same way, how many dots are there in 3 minutes? Well, 3 minutes would look like this, right? We kind of saw it on those examples that I showed you on the other page. But we'd add a dot here to each of these arms, right? This one right here, 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 here. Okay? So, how many dots would there be? Well, then we can count them once we complete the pattern. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 dots. Okay? Now, how many dots are there at 100 minutes? Okay? So there's multiple ways we can think through this one, but I kind of like to think through in table form. So at the beginning, before any minutes had passed, we had 1 dot. We started with 1 dot. Okay. At 2 minutes, or 1 minute, we had 5. At 2 minutes, we then had 9. And then 3 minutes, we had 13. Okay. So we should be able to see we're adding 4 dots each minute. Okay, so I could keep going on this table and just keep going till I get clear down to 100, right? And that would work. Okay, that would be a way that we could figure this out. Problem is that's going to take me some time, isn't it? Oh, not 37, right? That's 100. Okay, so maybe you figured out that, well, you maybe drew a connection and said, okay, if we looked at it kind of this way, we can see, okay, each minute we're getting 4 more dots. So at 100 minutes, there'd be 100 dots on each arm, right? Or 400 total, okay? Or 100 on each arm, plus the one we started in the middle. So we'd end up with 401 dots after 100 minutes. Okay, and then 4, how many dots are there in t minutes? Whenever you see that as a variable like that, it basically means they want some sort of formula. Okay? And it needs to work for every single situation. So to kind of think through this, there's a few different ways we can do it. Okay? If we are looking kind of at this first method, this kind of box one would kind of give you the same result. Okay, but if I'm thinking of this, I can say, okay, I started with that one. Then the next step, I added 4. Then I take that previous amount and I add 4 more. Then the previous amount and I add 4 more. So to get the next amount, okay, that's equal to my previous amount, and what did I do to it? I added 4. And I started with 1. Okay. Now, this is what we call a recursive formula, and we have a special way we like to write it. Well, there's a few different ways. We like to write for the next, we like to go a sub n. Then the previous is a sub n minus 1, and then how it's changing, plus 4. And then for where it started, we like to go a sub 0, and that would equal 1. Okay. Another way you can write it is a function notation style, where it looks like this. It's very similar. The difference is instead of that a sub n, you use f of n. Okay. So, all 3 of those sets, there's one formula, second formula, third formula. And we can see where it started. It's right there. And we can see that we take that previous, where we started, that previous one, and then we just add 4 to it. Okay? Just add those 4. So that's one way that you could come up with a formula to answer number 4. I suppose they use t, so I should probably have changed these variables to t's. Or this to t. Oh, that was supposed to be 0. Okay, that's one way of doing it. You can also think more explicitly, and I think this one helps with that. Okay, so you can say, okay, again, we started at 1. Okay, then each of these legs, and there's 4 of them, so there's 4 legs, and each leg is the number of minutes there are, right? 0 minutes, 0. 1 minute, there's 1. 2 minutes, 2. 3 minutes, 3. Okay, so we would times that by t, but then we always have to add that 1 back to it. Okay, and that would give us, the number we needed. Okay, so there's kind of another formula that you could use to help you with that. Okay, that's pretty much it. That's all we were really looking at right now is taking a look at these patterns and the sequences and kind of how we can think through them. Okay, there we go.